Hello! Today we are going to talk about how to solve 2x2 systems graphically and algebraically. Now, the majority of this should be review, so as we're going through it, if it's going a little too quickly, make sure you come in and see me for some extra help. A system of equations is a set of equations with the same unknown variables. Most of the time you have worked with just 2x2 equations. In class, we will focus more on 3x3. A solution set is the ordered pair that satisfies both equations, which means it yields a true statement. When you're graphing, you have three possible solutions. The first is that you have two lines that intersect. This means that you have one solution because there is one intersection point, and that we will label with whatever the point is, x comma y. The next option is infinitely many solutions. This means there are a lot of intersection points, which really means that there are two lines right on top of each other. They're intersecting everywhere, so they have infinitely many solutions. The last option is no solution. This means that the lines do not intersect at all, and that they are parallel. Now, when we are solving, we have a couple options: substitution, elimination, and solving by graphing. Substitution and elimination are the ones you're probably the most familiar with, so let's start with those. When you solve by substitution, you're looking for a variable that has a coefficient of +1. It doesn't matter whether it's x or y, it's just whichever one has a +1, and that's the variable you're going to solve for. So to do that, we will subtract our 2y over, and you'll get x equals -2y plus 2. So now, x is equal to this quantity here. So when we substitute, what we'll do is take -2y plus 2 and it will replace the x. So you're going to rewrite your new equation. And what that accomplishes is that now we just have y's instead of an x and a y. This means we can distribute and solve this like normal. Okay, so we'll go ahead and distribute. And combine your like terms. And subtract over the 10. And divide. And you should get y equals 3. So now remember, that's just the y coordinate of our intersection point. You also need the x coordinate. So now we'll take this y equals 3 and we'll just go ahead and plug it back in to find your x coordinate. And we'll write it as an ordered pair. There you go. So that's substitution. Next is elimination. Elimination, we want to keep our equations in standard form as these are, and you're going to multiply one equation by a number to get a variable to cancel with the other equation. So let's say I'd like to cancel my b's. Okay, I want to get rid of my b's. If this is an 8b, this one needs to be a -8b. So what I'll do is multiply this top equation by a -2. Make sure that the whole equation gets multiplied. And then the second one you can just copy down underneath. And you are adding these equations together. Now this is a special case because when we do add them together, everything cancels out. So on this side, you're just left with a 0. And on the right side, you're also left with a 0. This is when you have infinitely many solutions, one line on top of each other. So you can just leave it as IMS. Alright, so now we will go on to the back. Solve using a method of your choice. Well, this one isn't really set up very nicely for substitution. You could use substitution if you want, but you are going to end up with fractions if you solve for a variable. So elimination is probably your best bet. I am going to solve for x this time, cancel x, and to do that I'm going to multiply by a -3 for the first equation. That will give me a -6x for the top, which will add with +6x and cancel out. Okay, so again, be really careful to multiply everything. And we're going to add it with that second equation, and you'll notice again your x and y's cancel, which leaves you with a 0, but when you add the 10 and the negative 45, that gives you a negative 35. This is a false statement, and this means that we have parallel lines, which is no solution. Okay, so if you were to graph those lines, they would be parallel. So this one is a little different. This is a 3x2, 3 equations, 2 variables. We're going to start off treating it as the same. We're just going to do these two guys right here. And again, I prefer elimination, so I'm going to start with that. The best route is probably to multiply this top equation by 3 to get a negative 3y with that positive 3y. Bring this one down underneath. This time you notice the only thing that's going to cancel is the y's. That means we will have an intersection point. Get a 2. I'm going to plug that 2 back into one of these first two equations that I just did. I'm going to do the second one because I prefer addition to subtraction. Okay, so I'm just plugging that 2 into the second equation for x. And you should get that y equals 1. Now, ordinarily we would stop here and we'd say, yay, the intersection point is 2, 1. But that's only the intersection point for the first two lines. What we're trying to figure out here is if all 3 lines intersect at 2, 1. So, how can we do this? Well, you can do elimination again with these two equations. Or what's probably going to be faster is to just plug 2 and 1 into this equation and see if it actually works. If it does work, it means that that's the intersection point for all 3. And if it does not work, which in this case it does not, it means that this line doesn't intersect at 2, 1, which means that the first two lines intersect, but the third one does not, which means this is a no solution. Okay, it's possible to give you an idea of how this might look graphically. This is just an example. The first two lines are intersecting at 2, 1. This third line might be going like this. It might intersect both of those other lines at another place, but it's not intersecting at 2, 1. All right, we are going to end today with solving by graphing. So you're going to need your graphing calculator, obviously. We're just going to draw a sketch and we're going to round our answer to the nearest thousandth. So the first thing that you want to do is press second and stat plot and make sure that all of your plots are off. Okay, if you're not sure or if one of them says on, you can just press number 4 and enter and that will take care of it for you. You also want to press the zoom button and do a 6, zoom 6. This brings you back to a standard window. It should look like this. So now you should be all ready to graph. Go ahead and press the y equals button. Okay, so if we want to graph these, we do need to put them into slope-intercept form. Remember that means to solve for y. So go ahead and start moving things over. Okay, and this is something you should be really familiar with. Make sure when you divide by that negative 3 that you get a positive 2/3 x. And we're going to leave these as fractions. Go ahead and move that 4x over as well for the second one. And divide by your 5. Again, just leave all the fractions. Okay, go ahead and draw yourself a coordinate plane. Okay, and now here comes the fun part. When you go to y equals, there are 2 ways to type this into your calculator. Now, if you have the old operating system, there's only going to be one way to do this. And so we'll do that one first. y2, we'll try it the other way. If your calculator doesn't work, then just type it in the way I show you right now. So the old way to do this is that each fraction needs to be in parentheses. So parentheses, 2/3. The x button is right up here next to alpha. You don't have to do alpha and then find it down here. Just press the x button. Minus, parentheses, 1/3. Yep, that's what it was. Okay, now, you can do the exact same thing for y2. which is your second equation. But if you have the new operating system, then there's something else you can do. Everybody try pressing alpha, y equals, enter. And if you get this, that means you have the new operating system. And if nothing happened, then sorry, you have to do it the way we did in y1. But this creates a nice fraction bar for you, and then you can just type whatever you want in. So -4 fifths x plus 3 fifths. So you'll do plus, and again that's alpha, y equals, enter, 3 fifths. If you don't have the new operating system, it's not going to change anything. It just looks a little nicer. It's a little neater. That's it. Go ahead and press the graph button. And because these lines have different slopes, they should intersect. You're going to go ahead and draw me a sketch. Your intersection point looks like it's right between quadrant 1 and quadrant 4 here. When you draw it, make sure your intersection point is in the correct quadrant. Sometimes people don't draw it correctly, and it doesn't have to be perfect. Like mine is a little higher than it should be based on the scale of the graph on my calculator, but at least it's in the right quadrant. And now to find the intersection point, we press second trace. We want to find where they intersect, so 5, and then just press enter 3 times. We will round to the nearest thousandth, 0.636, 0.09, the 9 moves the 0 up 1. There you go. That's your answer. Okay. Last one. First equation, slope-intercept form. Great. Second equation, divide by 4. Now, you should notice that you do have the same slope, which means that these lines will be parallel. But you can graph it anyways. Feel free to put 1/2 as 0.5 if you'd like. Oops. .5x minus and graph. And you do have parallel lines, yay for us. Draw them in. And then since there's no intersection point, you can just put no solution. Now, if you do second trace 5, enter, 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 it's going to yell at you because there is no intersection point. See? That's bad. Alright, so there you go. Hopefully this was a good review of how to solve systems algebraically and graphically. If you have any questions, make sure you come see me tomorrow or ask in class. Have a good day.